Rational versus irrational numbers. Firstly, rational numbers can be written in the form of a all over b, which means that they are integers. And integers are negative and positive whole numbers. Meanwhile, irrational numbers are never-ending and non-repeating. So an example of this would be pi, because it's 3.14159 and ongoing. So it is never-ending and non-repeating. That means it's irrational. If I was given the surd 8, or you can say square root, you can use the terms interchangeably. If I were to try to break this surd down into the simplest form, I would have to find two numbers that when multiplied will give me the surd of 8, in this case, but one must be a perfect square or number, and the other must not. So, to break down this 8, I have to think of two multiples that when multiplied will give me 8, but one of them has to be a perfect number and the other not. So, the two numbers would be 4 and 2. So when two numbers are beside each other, just a reminder, they're multiplying. Now to simplify this even further, if we were to look at the surd of 4, this is a perfect square. So that means it can be broken down even again. So that's basically 2 multiplied by 2 will give us 4. So that means that the square root of 4 is rational. But now when we look at the square root of 2, well, we can't break that down any further. It's not a perfect square. So it's irrational. And even if you were to put this into the calculator, it would give you 1.41421356 and ongoing. So this shows that the square root of 2 is irrational because it is never ending and non-repeating. So the square root of 4 can be broken down into 2, and the square root of 2, we'll just leave it as that. And this is your answer of you simplifying surd of 8 to its simplest form. I'm given the surd of 48, and I'm told to break this down into the simplest form. Well, then I have to ask myself, two multiples of 48, that one is a perfect number and the other is not. 16 and 3. And 16, it is rational because it can be broken down into the number of 4, but 3 is irrational and cannot be broken down, so it'll be left as the surd of 3. Now, to emphasize how important it is to choose two multiples that one is a perfect square, is that if I were to do the same question and try and solve this by using two squares, then it would look something like this. So, for example, two multiples of 48 that are both perfect squares would be 4 and 12. Now, these two are multiplying to give us the 48. So, break this down. The square root of 4, we know that, it's 2. Now let's break down the 12. Square root of 4 and 3. Now let's break this down even further. That 4 can be simplified. So, we simplify it even further into a 2, and that's multiplying to the other 2. And then we still have the square root of 3, and then obviously we have to multiply. So that gives us 4 and the surd of 3. So it's important to choose one perfect number and one not, and it's okay if you can't, because you can solve it in the end, but it's a much more longer and time-consuming process. Now, what we're going to be focusing on is subtraction and addition when it comes to surds. And it's important to keep in mind of the whole rational and irrational terms when we look at subtraction and addition with surds. So, say for example, if I'm given this question, 5, the surd of 3, plus 4, and the surd of 3, take away 2 and the surd of 3. Now, two things to keep in mind when given these type of questions. Firstly, it must have the same surd. All of these surds, the 3, 3, and 3 are all the same, so we know of this. The second thing that we have to keep in mind is that the irrational with rational. So the rational parts will be subtracted and added. By that logic, we will take the rational parts, which is 5, 4, and 2, because remember they are positive or negative whole numbers that can be put in the form of a all over b. So 5 plus 4, 9, take 2, 8. So our answer will be 8, and then the same surd that we have, we'll just keep it as that in the end. Now another question that we can look at is 2 and the square root of 2 plus square root of 18. So firstly, they are not the same surds. We're going to have to break down this 18, especially because 2 can go into 18. So we must break down and simplify it. So two numbers or multiples, one is a perfect number and one is not. That gives us 18. Well, that's 9 and 2. We have the same surd, but our problem is that this surd of 9, well, it can be broken down. Then again, that will give us 3 and the surd of 2. Now, 2 plus 3, we keep the rational with the rational, and we add it in this case. So now if we were to make things a little bit more difficult, let's say if we have, then again, the surd of 18 plus surd of 32. And the more you do this, the more you kind of realize that you're just doing the same thing over and over again. In the last question, we had the surd of 18, and then we know that we're going to have to use the two multiples of 9 and 2, and the same goes for here. So, two multiples that multiplied will give us 18. One is a perfect number, one is not, is 9 and 2. Same applies for the surd of 32, will be 16 and 2. So now we have to look at the two numbers of 9 and 16. They're perfect numbers, so that means that they can be simplified down even further. The rational parts cannot, because they're never ending and non-repeating, and they cannot be put in the form of a all over b, so we leave them as it is. We take the 9, that can be cut down to 3, we leave the square root of 2. Now we look at 16, same thing goes, it's 4, and then 2. So we take the rational parts of 3 and 4 and we add them together. That gives us 7. And then the irrational parts, we keep them as it is, and that's 2.